Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 5, Lesson 5 on horizontal and vertical lines. Now we've spent quite a bit of time in geometry on lines in general. And in the coordinate plane, we've looked at how we can describe points along a line with either using the slope-intercept form of a line or the newly introduced point-slope form of a line. Today we're going to look at a couple very special types of lines, those that are parallel with the horizon, known as horizontal, and those that go straight up and down, known as vertical. So let's get into them right now. Now much of what we're going to be talking about today is review from your 8th grade math course and from Algebra 1, but still it's going to be essential in geometry to have complete fluency with these two types of lines. Now when describing points along a slanted line, an equation is necessary that relates the x and the y coordinates of any point that's on that line. However, horizontal and vertical lines have much simpler equations, and strangely enough in this case, sometimes simple can get confusing. So let's jump right into exercise 1 and talk about a horizontal line and a vertical line. Below, a horizontal line is shown in A and a vertical line is shown in B. Answer all questions about each line. All right, great. So in A, here we've got this line that's parallel to the horizon, and in B we have this nice vertical line, right, straight up and down. Now I've got 2 points marked off on each line, but as you know, every line contains an infinite number of points. These are just points that are sort of representative of them. So before we even move on, let's write down the coordinates of the 2 points on the horizontal line and the 2 points on the vertical line. So on the horizontal line, right, we've got the point -2, 7 and the point 4, 7, right? Those are the 2 points that I've marked off. On the vertical line, however, we've got the point 4, 8, and we've got the point 4, -3 in no particular order. All right, so just wanted to write down these 2 pairs of points, right, so that we just get a feeling for the points that are on the line. Now let's start to answer the questions. And I say we just kind of go back and forth on them. Of course, my 2 points now here. Maybe it would be better served if I put them down here and I can see them a little bit better. But let's talk about the first question. What is true about all points on this line? And let's talk about the horizontal line first. Right, immediately we can see something that's true if we just look at these 2 points. And hopefully what's pretty obvious is that if I pick any point on this horizontal line, let me take a look at that graph again, any point along that horizontal line, the y-coordinate is going to be equal to 7. Right? The x-coordinate could be a variety of different things, but the y-coordinate is going to be 7 because everywhere along this line, those points are 7 units above the x-axis. So all y-coordinates equal 7. And let's answer the same thing about letter B as well. Let's just kind of move right down the line. What's true about all the points on this vertical line? Well, we can notice right away that the x-coordinate of this point is 4 and the x-coordinate of that point is 4. In fact, if we took any single point along this line, we would find that its x-coordinate was 4, and that's because every point on this line is 4 units to the right of the y-axis. So in this case, what is true about all points in this line is all x-coordinates equal 4. And this brings us to a very simple thing in the second part of this problem. What would be a good equation to describe all points on this line? We're talking about the horizontal line right now. Well, it's really simple. Any equation whatsoever should tell you something that's true about points that lie either on a line, a circle, a parabola, or whatever. And what is true about every single point on this line is that the y-coordinate is equal to 7, and so the equation of this line is y equals 7. And that is deceptively simple, right? Deceptive because it almost appears like y equals 7 is not the equation of a line, but the equation of a single point. And a lot of students will get confused about that. They'll say, oh, y equals 7, that's just, I should just go up here and plot a y-coordinate of 7 along the y-axis. Well, there is a y-coordinate of 7 along the y-axis, but every single one of these points has a y-coordinate of 7. Now in terms of the vertical line, remember we talked here about the fact that every x-coordinate was equal to 4. And therefore, that is a wonderful equation to describe all the points that lie along this line. X equals 4. Very, very strange because we're so used to slanted lines having both x coordinates, both the x variable and the y variable in the equation. And that's because as you move along a slanted line, right, as you move along a slanted line, both the x coordinates and the y coordinates change, right? So you can't say, oh, y is equal to some number, just some number, or x is equal to just some number. But that is true for both horizontal and vertical lines. Now let's get into something that's very important, which is the slopes of these lines. So in the next part of the problem, it asks us, using the 2 points, calculate the slope of the line. Be sure to simplify it. So let me write down the points again for this horizontal line. And what we have here, right, is -2, 7. That almost looks like a 7. -2, 7, and 4, 7. All right, so if we use the slope formula, which is simply m equals y2 minus y1 over x2 minus x1, we get 0 divided by 6. Now, before we go on to simplify that, right, be very clear about this, right? The numerator of the slope is always the change in y, and y is simply not changing along this line. So it makes a lot of sense that the change in y is 0. The change in x, when I go from this point to this point, is 6 units because, x increased by 6 units. Now, look, it's very important to understand division when we do this because once we get over here, it's going to get a lot trickier, okay? If I have 0 cookies and I divide them up amongst 6 friends, how many cookies does each friend get? Well, they get 0, right? 0 divided by 6 is 0. And don't forget that fractions always do represent division. So if I put in 0 divided by 6, right, I get 0. Plain and simple. 0 divided by 6 is 0. Even if I did something like this, right, where I've got a fraction button on my calculator, right, and I do something like this, I can't even seem to get down here anymore. Nope. If I do 0, no, can't do it. Oh, there it is. And 6, right, and I ask my calculator to simplify it, it still tells me 0. Right? So horizontal lines have slopes equal to 0. And that makes sense, right? Because a slope is a measure of how steep a line is and whether it's going up or going down. That's the whole negative positive piece. But a flat line, right, we want to say that its slope is 0. Now let's talk about something that's far trickier, right? Which is the slope of a vertical line. Using the 2 marked points, calculate the slope of this line, try to simplify it, what happens? Okay, so let's take a look here. Our 2 points here are 4, -3, right, and 4, 8. So now, if I end up doing my slope formula, I have 8 minus -3 over 4 minus 4. 8 minus -3 is 11 because there's a rise of 11 there. 4 minus 4 is 0. And again, this should make sense just from the perspective of the slope formula, right? So the change in y was 11 between those 2 points, and the change in x was 0 because x didn't change. Now, what is 11 divided by 0? Okay, well, that is a much, much trickier question than something like 0 divided by 6. Now, the gut instinct by most students, or most people in general, would be 11 divided by 0 should be 0. How many times does 0 go into 11? Well, it can't go in there anytime because 0 is 0, right? Let's say that we ask our calculator exactly what 11 divided by 0 is. And it tells me divide by 0 error. Let's take a look at what happens if I try to put it in that fraction, right? Let's see if I can clear it out here. If I say 11 over 0, and I hit enter, it also says divide by 0, which makes a lot of sense because, again, the fraction bar is just the same as division. Divide by 0 error, all right? So I'm going to actually say, I'm just going to write down error here. Now, I'm not saying 11 divided by 0 is error, but we're going to talk about that a little bit. Eventually, what we're going to do is we're going to come to the conclusion that the slope of a vertical line is what's known as undefined, all right? Undefined, because vertical lines are simply infinitely steep, if you will. If we're going to assign a number to this whatsoever, we might want to say infinity, but we're not going to even do that. We're just going to say that you cannot define the slope of a vertical line. It's infinitely steep. But let's talk a little bit more about that question. Let's take a look at exercise number 2. For the vertical line, your slope calculation should have resulted in the expression 11 divided by 0, which is equivalent to, or 11 over 0, which is equivalent to 11 divided by 0. Why can this expression not be equal to any number? Question mark. Why is it undefined? All right. So I do want you to kind of think about this a little bit. This is probably the first time you've really had to face this, unless you really got into it in Algebra 1 as well. Now, before we talk about why 11 divided by 0 is undefined, make sure you just understand a few basic notions about division, or one basic notion about division, right? If I had 12 divided by 3, we all know that that's equal to 4, all right? And we know that it's equal to 4 for one simple reason, and that's because, right, 3 times 4 is equal to 12. All right, 12 divided by 3 is equal to 4 because 3 times 4 is 12. And that's how you first come to grips with division, is, oh, well, I know that this division is equal to that because this product is equal to that. And that works with all types of division, you know. In other words, if I have something like, 30 divided by 15 is equal to 2, that's because, right, 15 times 2 is equal to 30. I could even get kind of crazy with this, right? I could say something like, let me extend the page a bit here, right? I could say that 5 divided by 1/2 is equal to 10 because 1/2 times 10 is equal to 5. All right, so you have to understand this sort of, relationship between division and multiplication. You have to understand that, right? Not only do you have to understand it, you have to understand it well enough that music just plays in your head when you see it. Now, we can finally address why 11 divided by 0 is non-existent, right? So let's just say 11 divided by 0 was equal to some number, right? And we asked ourselves, what would that number have to be? Well, whatever that number would have to be would be a number that 0 times that number would be equal to 11. Right? So if 11 divided by 0 is actually equal to a number, whatever it is, whether it's 0, whether it's 22, whether it's 1,000, whether it's a number that we'll call Fred, I don't know. But if 11 divided by 0 is equal to a number, then 0 times that number must be 11. But 0 has this cool property where 0 times anything is 0, right? 0 times anything is 0. And therefore, there is no way that such a number can exist. There is no number that when you multiply it by 0 can possibly be 11. And that is why you cannot divide by 0. All right? If you could divide by 0, then we could have a number such that 0 times that number would be equal to whatever you're dividing into, and you just can't do it. All right, so let's summarize all of this about horizontal and vertical lines right here in exercise number 3. Fill in the following for horizontal and vertical lines. For horizontal lines, number 1, they are parallel to, well, they're parallel to the x-axis. And they have equations of the form y equals a number, right? So in our last problem, right, it was y equals 7. And finally, they have slopes equal to 0, right? The slope of a horizontal line is equal to 0. And that should make all the sense in the world because they're flat, right? They're flat. They have no steepness. I can roller skate on them very easily, right? Vertical lines, right, they're parallel, not to the x-axis, but to the y-axis, right? They have equations of the form x equals a number. And finally, the trickiest part about vertical lines is that they have slopes that are undefined, right? You cannot define the slope of a vertical line. In other words, slope is a number, right? And we simply can't define a number that could be assigned to that slope. If it's so, it would have to be infinity, and again, we don't tend to do that. Okay, let's keep playing around with horizontal and vertical lines. Now for us, horizontal and vertical lines are going to be like workhorses in terms of a variety of different things. And one of the things they do well is they help us to do what's called bounding an area. We will often use slanted horizontal and vertical lines to enclose or to bound a portion of the coordinate plane. You know, whether we're modeling something or just trying to like create a shape in the coordinate plane, it's helpful to have these types of lines. So let's take a look at exercise number 4. Graph the 3 lines below. Label each with its own equation and shade the region that is enclosed. All right. Well, you should have a sense, especially for how to graph y equals negative 5/3 x plus 4. Why don't you pause the video now and go ahead and graph that slanted line using its slope of negative 5/3 and its y-intercept of 4, and then we'll come back and together we'll graph those vertical and horizontal lines. All right, well, let me just get rid of my ruler here for a second. Just want to point out the fact, right, that in this slanted line, my slope is negative 5/3 and my y-intercept is 4. So I'm just going to simply come over here, go up to a y-coordinate of 4 on the y-axis, and then I'm going to go down 1, 2, 3, 4, 5, and go over 3. And then 1, 2, 3, 4, 5, and go over 3. That should be enough to establish a good line for myself. I just now need to use my straight edge effectively and do that. Whenever we're graphing more than one line in the coordinate plane, we should always make sure to write down the equations of the lines. All right, so we know the equation of this line, can't get that blue box off, there we go, is y equals negative 5/3 x plus 4, so we'll just label it. All right, now, for x equals 6 and y equals 9, probably the most common mistake that people make with vertical and horizontal lines is they just forget which is which. One of the easy ways, though, of making sure that doesn't happen is when you get something like x equals 6, write down some coordinate points that make that true. So for instance, for x equals 6, right, one point that will make that true is 6, 0. Another one that'll make it true is 6, 5. Another one that'll make it true is 6, negative 2. Right? And if you think about that, right, 6, 0, that's simple. That's right over here. 6, 5, that's easy. It's right here. 6, negative 3, that's right here. And as soon as you've plotted those 3 points, it should be pretty clear that we're talking about a vertical line there. Right? So we can, in fact, just turn our ruler vertically, hopefully. There we go. Bring it over here. And let's graph this vertical line. Excellent. Right? And that's our line x equals 6. And then we can do exactly the same thing with y equals 9. We could write down a bunch of points that have y coordinates of 9. So for example, 0, 9, 5, 9, negative 3, 9. These all make that true because they have a y coordinate of 9. So here's my 0, 9. Here is 5, 9. Here is negative 3, 9. Right? And again, that should be enough that once we have it, it's pretty easy for us to realize that we've got a horizontal line, and we can draw our line. And we can label it. Now, what you should be able to see as well, once we've done that, is that those 3 lines enclose a triangular region. And in fact, it says shade the region that's enclosed. Right? Not the greatest shading job, but you understand what I mean. Maybe I should put a little shading in here and get a little bit closer there as well. There we go. So if for some reason I was trying to model, let's say, a playground that had a triangular footprint, right? These might be good ways to do it. In other words, I might need horizontal and vertical lines to model that shape. All right, let's keep going. Let's work with them a little bit more. Now, let's talk about line reflections. We worked with those extensively in Unit 2, right? We even did some line reflections in terms of sort of our coordinate grid. But almost always back then, we were reflecting across either the x-axis or the y-axis, which were very specifically, vertical and horizontal lines. But now we can reflect across any random vertical or horizontal line, right? We can now consider reflecting points and figures across vertical and horizontal lines other than the x and the y-axis. So let's take a look at exercise number 5. Given triangle ABC shown below, plot its reflection across the line y equals -2. Label the image triangle A', B', C'. Show how the 3 vertices get mapped below. All right, well, the most important thing here is to begin by graphing the line y equals -2 so that we can really see the line that we're trying to reflect our triangle across. So pause the video now and graph the line y equals -2 on this coordinate grid. All right, well, if you need to plot points again for this particular line, that's great. Eventually, I hope you're able to look at this and say, y equals -2. That's a horizontal line, right, that has simply been shifted, or is simply 2 units below the x-axis. So I'm going to graph y equals -2 on my coordinate grid. And now I've got something to work with, right? And we could start with point A, right? Point A, we want to reflect across y equals 2. And we know, of course, that it's going to sort of just move vertically because the vertical direction will be perpendicular to this horizontal line. Now, right now, point A sits 3 units below y equals -2. When we reflect it across y equals -2, it will end up 3 units above. So I can immediately just sort of do that by counting. And what I'll see is that A, which is sitting at -8, -5, will get mapped to A prime, which is now at -8, +1. All right, that's it so far. Great. Now let's take a look. Maybe we'll do point B. So right now, point B is sitting 1, 2, 3, 4, 5, 6 units above y equals -2. It will then end up 6 units below y equals -2. In other words, it will be at a y coordinate of -8, right? So let me just label that B prime. This is A prime. So I've got B, which is at -4, 4. Will then map to B prime, which is at -4, -8. All right, and finally, when I look at point C now is at, how many units do we have? We've got 5 units below y equals -2. It will be now 5 units above -2, which will be at +3. Right, let me just make sure. 1, 2, 3, 4, 5, you bet. 1, 2, 3, 4, 5. Right? So we've got C sitting at 6, -7, and that ends up being mapped to C prime, which is at 6, +3. The only thing left for us at this point is to actually draw in our triangle by using our nice straight edge to connect all the dots. So we'll end up there. Oh, nope. Silly ruler. There. And there. Excellent. All right, right? Simple as that. Really a counting issue, right? Because we know if we've got a horizontal line, then the points are going to reflect vertically. And of course, if we had a vertical line, the points would reflect horizontally. And we have to be ready to be able to reflect points across any horizontal or vertical line whose equation is given to us. All right, let's take a look at one more, exercise number 6. In the diagram given, triangle M'N', P' is the image of triangle MNP after a line reflection. Letter A, draw the line of reflection, and letter B, state the equation of the line of reflection below. All right, I'd like you to pause the video right now and see if you can figure out where the line of reflection is. See if you can graph it. And as a little hint, there's two ways or two things that are helpful for you when you're trying to find a line of reflection. One, remember that that line of reflection has to bisect or go through the midpoint of any segment that joins a pre-image point with its image point, right? It's got to bisect that segment. The other piece is, of course, that any points that lie on the line of reflection will not move when they're reflected across it, all right? Those two things can help you find the line of reflection in this case. Pause the video now and see if you can graph it. All right, well, let me just take a look at point P and point P prime. If I took a look at these 2 points, and let me just hand sketch in a line segment that connects them, right? The line of reflection has to bisect that segment. So it's got to go through that line. That's the midpoint of that line segment. Likewise, if I connected N and N prime, again, it would have to go through the midpoint of the line that connects those two, or the line segment that connects those two. So it would have to go through that point. And I could do the same with M and M prime. Although those 2 points are enough to get the job done, it's kind of helpful to see that it must also go through that point. So it's got to be a vertical line. And now I can pretty much easily graph it by just bringing my line or my ruler up and drawing it in. Also note, right, that those 2 points that I circle, right, where this image intersects its pre-image, right, those are points that had to have lied on the line of reflection because they didn't go anywhere. They stayed in the same place. All right, so we've got a vertical line. That's part A. Now the question is, what is the equation of that line? Well, since it's a vertical line, it must have an equation that looks like x equals a number, and x will be equal to whatever the number is that is the x-coordinate of every point that lies on that line. Well, for instance, this particular point, that's got the coordinate 4, 8, right? This particular point, that's 4, 2. This particular point, that's 4, -6. So it looks like our equation is just x equals 4. All right, and that is not an uncommon question, right? Is what line of reflection, what is the equation of the line of reflection to produce a particular image? All right, let's wrap this up. Now, really, everything that we saw today in terms of what does the equation of a horizontal line look like, what does the equation of a vertical line look like, all of that you should have been seeing really since Math 8, 8th grade math. The one thing that may have been a little bit new today was simply the idea that the slope of a vertical line can't be quantified. You can't assign a number to it, and therefore we call the slope of a vertical line undefined. The slope of a horizontal line, right, something that's parallel with the horizon, well, that's got a slope of 0, and that should make sense totally because it's not steep at all. On the other hand, a vertical line is infinitely steep, right? And therefore, we can't define a number that gives us its slope. Besides that, though, you should definitely commit to memory the idea that a horizontal line has an equation of the form y equals a number, and a vertical line has an equation of the form x equals a number. We're going to see these quite a bit as we move forward in this unit and throughout the course, so make sure to really try to nail them down on the homework. For now, I'd just like to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.